line fault occurs, the fast and complete evaluation of the failure is crucial. Protection devices therefore record almost all analog measured signals as fault records during a network fault. A suitable operating software for SIPROTEC devices, its DIGSI-4, reads out these fault records and stores them. The standard format for the fault recording is called COMTRADE. The data is thereby divided into two files. The so-called configuration file, which you can recognize by the ending CFG, describes the fault record channels. It supplies information on signal names, sampling intervals, channel numbers, and more. The actual measured values, the sampling values of the fault record channels, are stored in a file ending in DAT. In order to draw the correct conclusions from the stored data, all you need now is a professional evaluation tool such as SIGRA-4. SIGRA-4 is a standalone software. You can therefore start it independent from other applications and, thanks to the internationally standardized data format COMTRADE, open and evaluate fault records of different vendors. If you use SIPROTEC 4 devices and therefore work with DIGSI-4, you naturally capitalize on the seamless integration of SIGRA-4. A double click on the fault record icon is enough for SIGRA-4 to open it. With this, you're not only faster, you also receive additional information. For DIGSI-4 automatically generates a so-called RIO file with protection settings for distance protection. Included, among other things, are earth impedance factors or tripping characteristics. SIGRA-4 evaluates this file and so saves you the manual input of this data, for example, in the network configuration. After you have opened the fault record, SIGRA-4 first shows the sampling values as time signals. From the standard RMS value representation, you switch to the instantaneous value representation with only one mouse click. If you shift the display with the vertical scroll bars, you will not only see additional analog signal sequences, but also so-called binary tracks. These show you the response of the protection device, in other words, the point in time of the tripping and the command duration, for example. As you've already learned in the introduction of the CD, SIGRA-4 offers you a series of further display modes. With a mouse click in the toolbar, or also with the help of the menu, you can easily switch between the various views. With SIGRA-4, you decide which information is shown. This way, you easily supplement the already existing diagrams of a view by a new one. You then assign the individual signals to the existing diagrams with the help of a table-like dialog, which we will briefly look at in more detail. In the vertical direction, all available signals are compiled in groups, for example, analog signals, binary signals, or distance zones. In the horizontal direction, the existing diagrams are offered as the targets. These are sorted according to the various views. If you only want to concentrate on one particular section of the table, you show or hide lines and columns. This way, you easily optimize your individual view. With a mouse click, you ultimately assign a signal to a diagram quickly and intuitively, or you remove it once more. At this time, you can also determine how a signal is to be displayed in the diagram. With color, line types, and thicknesses, as well as with different markings, you vary how everything looks and so make the individual signals distinguishable. One click on OK and SIGRA-4 accepts your settings. A further click closes the dialog box, and once more you have a clear view of the diagrams. Do you also want to use certain visual signal configurations for other fault records? Our tip: save these configurations as user profiles. We will show you how simple that is in a little example. For this, we have optimized the time signals view for our black and white printout. In this, the individual signal sequences differentiate themselves through different markings instead of colors. A click on the button next to the selection list for the user profiles opens an input dialog. Here, you assign a name for the profile and optionally supplement it with an additional comment. You only have to click OK, and SIGRA-4 stores all current settings as a user profile under the defined name. For all other printer tasks, you now have the appropriate representation ready in no time, because you easily select the desired user profile from a selection list in the toolbar. If you would like to make fault records available to other evaluation programs or even testing equipment, the export function in SIGRA-4 with its different setting possibilities is particularly helpful. Through the specific selection of individual options, you adapt a fault record to the requirements of the target application and so very nicely avoid compatibility problems. Regardless of the target application, you select the actual signal information. For that, you arrange the designations of all signals that SIGRA-4 is to export in the right selection window. Now you only have to define a name and a storage location for the data. SIGRA-4 takes care of everything else. Quite easily, you also export diagrams and table values in order to further process these in different Office software. Regardless of whether the target is a word processor, a presentation tool, or a spreadsheet, the task is a breeze. For example, time signals. Select one or more diagrams, and while keeping the mouse button pressed down, drag them into the target document. Finished. There's nothing else to do. One tip: you get the best visual results if you already scale the graphics to the required size in SIGRA-4. With drag and drop, you can also copy the displayed table values. If the target is a text document, the values are first inserted as text. To reproduce the column structure, you simply convert the text into a table. When you insert the values in a spreadsheet, you completely retain the column arrangement. You can start immediately and format the data according to your needs and taste. In our first practical example, a transformer is switched on. As a result, the protective device trips. In order to attain clarity about the cause, we will analyze the fault record with SIGRA-4. The fault was recorded by a Siemens SIGRA-4 7UT6. This relay records currents and voltages on the primary side of the transformer as well as on its secondary side. With DIGSI-4, you read out the fault data through an online connection to the device, for example by modem. For this, you require only a few mouse clicks in DIGSI-4 after the connection has been made and the individual measuring signals are displayed directly in SIGRA-4. After the fault record has been opened for the first time, SIGRA-4 displays each analog signal as an individual diagram. All binary signals are compiled in one common diagram. Through the different prefixes K1 and K2, the primary side and secondary side currents can easily be differentiated. To design the view more clearly, we will first of all mask some of the signals that are not relevant for our analysis. Among others, it's the two primary side currents I7 and I8. With the dialog Assign Signals, you do this for all views, even those that you don't have open at the moment. With a mouse click, you deselect the individual signals, or you remove complete diagrams by deleting the associated column. Here's a tip. You can also select diagrams directly in the respective view and then delete them. What's important, the actual information, in other words, the measured signal, is retained. With the Assign Signals dialog, you can reassign this to a diagram at any time. We still want to summarize the primary side differential currents and restrained currents in a diagram each. Why don't you give it a try with drag and drop? All you have to do is select the designation of a diagram and drag this onto the designation of another diagram. This way, you can compile several signal sequences of one type, in other words, currents and voltages, for example, in groups. You then select and delete the leftover empty diagrams. The diagrams for the primary side currents in the individual phases show us a starting current in rush that is dying out. This is caused by the saturation of the iron in the transformer. The distorted sine oscillation can be clearly recognized. For these signal sequences, we first of all want to optimize the scale. To do so, open the Properties dialog for the uppermost diagram and show the additional input possibilities for the diagram scale. In this case, select -2.5 as the initial value for the y-axis and define the end value as 2. Then click OK, and SIGRA-4 assigns the new scale to the diagram. Now all you have to do is adjust the other two diagrams. With the right mouse button, open the shortcut menu of the already optimized diagram and select the command Match. That way, the other two diagrams are given the same scale as the already optimized one. Now let's have a look at the secondary side current sequence. The phase currents are constant 0 here. The transformer winding was not yet sufficiently saturated when the protective device tripped. In order to find out more about the cause of the trip, we'll throw a glance at the binary tracks. You'll see right away that the binary track for the second harmonic in phase 3 is considerably shorter than those for the other two phases. What's more, the end of the binary track and the beginning of the trip occur at the same point in time. Obviously, the content of the second harmonic in phase 3 fell below the threshold value, which led to the trip. You can get more clarity by looking at the harmonics as a bar graph. The best thing to do is minimize the window with the time signals and then open the view for the harmonics. That way you have their progress in sight while you move the cursor along the time signals. First, activate the function Magnetic Cursor Lines. Now you can position the cursor exactly at the beginning of the binary tracks for the 3 phases. Right from the start, the portion of the second harmonic in phase 3 is less than in the other 2 phases. When you move the cursor to the right, you will see that this content also decreases more suddenly than in phase 1 and 2. If you are interested in exact values of the progress, the table of values will be helpful to you. Open this in addition to the 2 other windows. In order to optimally position the 3 windows, simply click on the additional button in the title bars of both windows. The table of values can easily be adapted to your personal needs. With the Properties dialog, you select what you require from the available information. For the current task, we decide on the amount, the RMS, the direct component in percent, and the second harmonic also in percent. Now position the cursor at the end of the binary track for phase 3. In the table, you can read out, in addition to other values, the content of the second harmonic at this point in time, in our case 24.9%. Conclusion: the threshold value for the second harmonic was selected too high and doesn't correspond to the Siemens recommended value of 15%. The current setting should therefore be definitely changed. In our second practical example, we will look at a line fault. At both ends of the line, a distance protection device records a fault record. At end A, this device is a Siemens SIGRA-4 7SA522. At end B, the device of another vendor will be used for this task. With SIGRA-4, the first thing we open is the fault record for line end A. We have already read out and saved this from the SIGRA device with DIGSI-4. First of all, we group several signal sequences of one type each in a diagram. To do so, we simply select one of the standard user profiles. If you would like to have a better view of the binary signals, place them at the uppermost location in the view using drag and drop. Let's briefly look at the track Carrier Signal Received. This tells you when and for how long an indication came in from the opposite side, in other words, from the second protection device. To measure the duration of this indication, for example, use the 2 cursors. Position cursor 1 at the beginning of the indication. Shift cursor 2 to the end of the binary signal. The difference between the 2 points in time results in the duration, whose value SIGRA-4 shows directly in the table above the time signals. Now open the circle diagram view. This view shows the sequence of the fault within the impedance level and also the individual distance zones of the protection device. This is possible because SIGRA-4 puts the information about the tripping characteristic of the 7SA522 in a so-called RIO file, which is evaluated by SIGRA-4, a benefit which pays off. For now, you only have to shift the cursor, and you can see immediately how the fault progresses within the individual zones. Simply pay attention to the crosshairs that move synchronous to the cursor along the circle diagram. Here's a helpful tip on the side. Individual zone passages can very easily be marked with user-defined status signals in the time variation. Practical, especially if you later want to work with the time signals. You can not only take the designation of a zone from the legend, a tooltip also reveals the name as soon as you position the mouse pointer on the respective limit. Of course, you also want to know where in the line the fault occurred. The sophisticated fault locator from SIGRA-4 will help you to sensibly locate the affected area. In addition to a one-sided fault location, SIGRA-4 also masters the two-sided location of a fault and thus provides precise results free of influences through the zero sequence system and the in-feed conditions. For this, SIGRA-4 includes the fault record of the other side of the line in its calculations. You add the second fault record to the already opened one. The measured signals of the second fault record are inserted after the signals of the first. You can easily recognize the newly added signals by the prefix K2. In the dialog for the network configuration, now enter the actual values for the line length, the reactance, and the resistance. The often only vaguely known earth impedance conditions are not required by the calculation procedure. Now start the fault locator. You do this with a mouse click on the button in the toolbar. SIGRA-4 first of all synchronizes the signals of both fault records on one common time base and then calculates the fault location. A graphic shows you the possible areas of the fault as a result. Since SIGRA-4 also evaluates each fault record individually, you see three curves, one for each of the one-sided fault locations and an additional curve for the two-sided fault location. Based on the qualities determined, you can simply read the most probable fault location. As a rule, the two-sided fault location will have the highest quality, as is the case in our example. SIGRA-4 also displays values in the comment area above the graphic. Information about the type of fault, the distance to the fault location, or the impedance of the fault loop thus add detail to the calculation results.